Hello and welcome to another video. In this video we're going to be continuing on with the blind 75 in Typescript, and we're going to be doing 3-sum. So in this problem you're given an array of numbers and you want to return all triplets such that the three numbers equal 0 but they're not at the same index. So for this example here we want to return this and this. We also don't want to return duplicates, so we want to make sure that all of these are unique. So we don't want to return something like 2, -1, -1, and so on. So we want to make sure they're all unique, as it says here. And so that's going to be like the tough part of this problem. So for this first one, -1, -1, 2 is a triplet, and it's also -1, 0, 1. Okay, now for this second one, it's not possible to have a triplet because this is the only triplet and it does not sum up to 0. And for the last one, this sums up to 0, and this is the only triplet. So we're actually going to focus on this example 1. And what we're going to do is we are actually going to figure out like how to do this problem. Okay. So let's say we have some numbers. Like let's say we have, some numbers and they are in a sorted order. Say like this, and we have a target, right? This is like the 2-sum original problem. Let's say our target is something like, we want to make sure we have a unique answer. I guess in this, I guess you do have a unique answer. Let's say the target is like 8. So how did we do this problem here, right? In the 2-sum sorted order. And so I would encourage you to do the 2-sum array sorted. But essentially what happens is you have a left and a right pointer, and you just check for your two numbers, you add them together, and you try to make them equal to target. So here, for example, we would have 6, and we would say, okay, it's too small. Now the right is the bigger number and the left is the smaller number. So if we need to increase our number, we're going to move the left to the right. So we'd move it here. And if we want to decrease, then we're going to move the right this way. And so here we would have 7 now. So here we'd have 7, and it's still too small. So we're going to shift the right or the left again. And now we have 8, and that's our answer. And so we would return 3 and 5. And so we're going to do this with a O of 1 solution for this problem. And the way we're going to do this is we're basically using that, but we also need to include one more step. So first we're actually going to sort our numbers. So let's see what that looks like. So we're going to focus on this example over here. So if we sort our numbers, we get -4. And because this is going to be an n-squared solution, sorting our numbers is essentially free. So if sorting helps you and you have an n-squared or n log n solution, you should always sort because it's basically a free operation. And in this case, we will have that. And obviously we could do like the worst case time complexity here would be O of n cubed, right, where we just manually look through every single combination. But we're not going to do that. We're going to do an n-squared with an O of 1 space. So if we sort our numbers, we have -4, -1, -1, 0, 1, 2. And essentially we are looking for all numbers that add up to 0. So let's just do that here. So let's have a result. Here it's going to be an array. And then we're going to have like an index. We're going to have a left index, and our left index, let's say, not a left index, but more like an index as we are in the, maybe we'll call this, like the I or something. So let's call this I. It's going to start here. And essentially all we're going to do is we are going to, remember we need three numbers that add up to 0. So we need x plus y plus z that add up to 0. So for the index we're on, we can just subtract that from 0. So let's call this x. Yeah, it's probably a better name, right? So let's call this x. And this x, now what we can do is we can just subtract it. So we can just say y plus z equals 0 minus x. And so y plus z here equals 0 minus -4, which is 4. So we are looking for a y and a z in this part that add up to 4, and anytime we have that, we can do stuff with it. So let's look at that. So essentially, what's going to happen is we are going to, So what's going to happen is we are going to make a left and a right. So we're going to make a left here and a right here, and we're essentially looking for two numbers that add up to 4. Because if we find two numbers that add up to 4, we took into account this x, right? So here, these two numbers add up to 1, so clearly it's too small, so we're going to need to move to the left. So here they still add up to 1, too small, let's move to the left. You could make some slight optimizations, but I'll talk about where the optimizations are actually needed to avoid duplicates. But for now, we're good. So, okay. So now we make it here, and it's 2 too small, and then finally it's 3 too small, and now we can move this again, but now the left is no longer less than the right, so we didn't find anything here. So for this x value, we didn't find anything, so let's just go back and delete all of that. And now let's reset our x value so we can actually delete it here. Okay, so our x value now is over here. And so our new target is 1, right? Because it's 0 minus -1. So we're looking for two numbers that add up to 1. Okay, because 0 minus x, right? So y plus z need to equal 1. Okay, now we're going to search in this section. Okay, so let's do that. So we're going to start here and start here. And we happen to see, hey, these actually do add up to 1. So this is a solution. So -1, -1, 2 is the solution. So we're going to write that into our result. -1, -1, 2. Okay. And now I'll kind of show you. So we didn't really run into it, but let's say we happen to have another -1 here. So you could see, like, if we had another -1, and let's just say our algorithm was like, if we find, we have to keep, so in our two-sum, we just found one solution, but here we need to look for all possible solutions, because we could very well have like -1 and 2 other numbers, just like it's shown here, right? So -1, -1, 2 is a solution, but also -1, 0, 1 is a solution. So once these two are found, we need to actually move one of them and keep looking for more solutions. But we can't just move one of them once, because then we'd have the same thing. So for example, if we just say, like, okay, let's say that we have this array, and once we found a solution, we're just going to move the left or the right. Let's say we move the left. Well, now we're going to get the same solution, right? So we can't just move it once. What we actually have to do is we actually have to move one of them enough times to where it's no longer on the same number. So essentially we can say, like, let's just move the left until it's no longer the same number that it used to be or out of bounds. So we're going to move it over here, and then we're going to say, okay, well, that's the same, so we have to move it again. So now we'll move it over here, right? So that's what we have to do. But we only have to do that. You could technically do that. Yeah, I think you could do that every time you move the left, but that doesn't really matter. The important thing is, once you do find a solution, you need to move either the left or the right enough times to make sure you're not on the same number, right? Because, like, let's say you had a 2 here, same thing. You can't just move the right one, so you have to move it more, otherwise you're going to get duplicates. So that's one thing that it's important, that when the left equals the right, we can actually write that down here. So when left plus right equals target, we need move the left until we hit new number. And you can either move the left, you can move the right, you know, you can do it at a much different ways, but essentially you have to move it enough to hit a new number. So it was here, then we moved it here, and it's still the same number, so now we have to move it here. So that's where we're at here. So we're actually going to delete these because the left is technically here, and we are going to get rid of this -1. I just want to show that as an example of duplicates that you would want to avoid. Okay, so now 0, 2, this is 2, we are looking for a 1. This is too big. So because it's too big, we need to move the right to the left. And now we have another solution here, right? So -1, 0, 1, so we're going to write that in. Okay, that's another solution. Now we don't have any more, because once we find the solution, once we move the left or the right, you know, we don't have any more. Okay, now there is one other thing we need to do to avoid duplicates. So let's just say we, let's make sure the 2 is still there. Let's just say we just say, like, okay, we're moving on. Let's move this x over here and do the same thing. Well, as you notice, for this x, you are going to get these two values, which is the same as before. And if you don't want to use like a set or something, the way to avoid that value, the way to avoid that is whenever you move your x value up, you also, every single time, regardless of if you found a solution or not, I guess technically if you didn't find a solution, you wouldn't have to move the x up, but you can always just move it up because essentially you've already looked through everything there, right? So like if we look through this x value, we've looked through this array, and if we found something, we're going to get it again, or we're very likely to get it again, and we don't want that. And if we didn't find something, then we're going to have this x value and a smaller array, so we're definitely not going to find anything again, right? So either way, whenever you move this x value, you need to make sure that every time you move it, it moves to a unique value. So that's our other duplicate check, is whenever we move our x value, we need to make sure it's not on the same one. So we don't want to move it from here to here. We actually want to move it over here. Okay, and so now our x value will be here, and now our left and our right are over here. And now clearly these need to add up to 0, so they do not. So we are just done, pretty much. Because after that, our x value would be over here, and then our left, it would be here, and our right would be here as well, which wouldn't satisfy the condition. Left has to be less than right. And then finally for this x value, the left would be out of bounds, so we're done. Okay, so that's our stuff. And so we can write down again the thing that we need to avoid. So when we move the x value, we need to move to a new unique value. And then the other thing is when we move L or R, once we found a solution, those have to move to a new value as well. And so these are 2 cases to avoid duplicates. And now if you think about it, we didn't really use any, we didn't really use a hash map or anything. We just sorted, and then we look through our stuff, and we just have 3 pointers. So this would be an O1 solution, assuming you don't count, and most people don't, space to sort. And you also don't count space for your result. So that's going to be O1 space solution, and it's going to be n squared time, but we'll get into that later. So now we can start coding. So let's get into it. So here is our 3-sum function. And let's actually code it up now. And I will say this function is pretty tricky. The main thing about this is just like logic errors and where to move stuff and where to not. So drawing it out really helps, and walking through your thought process in a drawing like I did helps you save a ton of time. It really makes it easy to recognize stuff. Also, like I said, you could use this Quoco, which I'll show you as well. I showed it in some other videos, but super helpful for debugging. Okay, so we're going to sort the nums, but if you notice, and I can actually show this here. So let's say we call this function, let's just say console log 3sum, and we are going to give it actually that array. I don't remember the exact order, but let's just say it roughly. I think it's like -1, 0, -4, and then it had one more -1, and then a 1 and a 2, I think. Okay. So this is printing undefined, but look what happens here. Well, that's weird, right? Our sort is incorrect. And the reason for this is because in JavaScript, as opposed to Python, when you sort, you're actually just comparing, like, what it does is it turns the numbers into strings and then compares them. I don't know if it says it in here. Sort function. Yeah, so essentially, this doesn't actually compare the numbers, it compares them as strings, and so these negatives are going to be a problem. Okay. So what we need to do is we need to actually make a custom comparator, and this is easy in JavaScript. In Python, it's actually a little bit more annoying, but I guess the sorting algorithm in Java is worse. So essentially what you do is you write a function that takes A and B, and what you want to do is you want to return a negative value if A is less than B, and then you want to return a positive value if A is greater than B. Yeah. So the way to do that would just be A minus B, right? Because then if A is smaller than B, this will be negative, and if A is greater than B, it will be positive. So that's how you want to sort. And now if we console log again, nums, now we have it correctly. And so this is why Quoco is also useful. You can just keep console logging whenever you want, and it shows it to you right away. Okay, so now there's another tricky TypeScript thing. We need to make a result array, but we need to make it a nested array, right? Or like our array is going to look like something like an array of arrays. And so the way to do that in TypeScript is you can actually write number, and then you just do array. And that would be a nested array of numbers. Okay. So now we're going to do this x value thing. But instead of x, we're going to use the I. So we're going to say let I equals 0, and then I is less than nums.length. And then we're going to use another couple of features of JavaScript that are going to be useful for us that aren't in Python, and I'll talk about those as well. So now we're going to make a target, like I said right before, so we're going to have a target. And in TypeScript, you don't need to, I said this before, you don't need to give it a type if you already give it a value that's an integer. So that is the target we're looking for, and now what we need to do is we need to declare left and right, so we can say let L equals I plus 1, right? And then we can also say right equals nums length minus 1, right? The last value. There we go. Now we can have our loop for the while less is less than right. We have to look for all of our answers, not just one this time. Okay. So we're actually going to get a total here. So let's just say like let total equals nums L, because we're going to be reusing this, so we don't want to have to keep doing nums left plus nums right. Okay. And now what we need to do is we have a few conditions, right? So if the total is equal to the target, that means we have a solution. So let's handle that first. So what we first need to do is we need to do res.push. So the values we're going to be pushing is nums I, right? That's the first value. And then the second value is nums left and nums right. Those are our 3 values. Okay. Now remember, so what I said is if you're left, the way to like make this go further, if you found something, is you need to actually move the left or the right. But we need to make sure we move the left or the right enough times to avoid running into a duplicate, right? So if our left is a 1 and we move it and we get a 1 again, we need to keep moving it. And so this is where we use one useful feature of JavaScript, where we could just say while nums left plus 1 equals nums.left, we can just keep moving it. And you might think like, oh, we can be out of bounds. Well, the nice thing for a JavaScript array, and same thing for TypeScript, is when you're out of bounds in a JavaScript or TypeScript array, you will return undefined, right? Where in Python, you're going to get an error. So in Python, you would have to check, are you in bounds? But in JavaScript, you don't, and we have an array of numbers. So as soon as we're undefined, that's fine as well. Okay, so while the number's the same, let's just increment. And now, if we had an array like this, right, let's say we had like 1, 1, 1, 2, 3, and this was our left, we would move, now the left would be all the way at the end, but then we need to move it one more time after that, so we're just going to say left plus plus again. And there we go. So essentially, this while loop will execute, and if you haven't seen a while loop without brackets, it's just because you can still have a one-liner while loop without brackets, and it'll still execute, just like an if statement with only one line of code. Okay. So now that we have that handled, now we have to handle our other cases. That's going to avoid duplicates when we find an answer. So now we're going to have an else if, and what other conditions do we have? So we have a total is less than target. And so if the total is less than target, that part's pretty straightforward. That means, remember, the right is the big number and the left is the small number. So we need to increase our number. So we're going to do left plus plus. And then last case, it's bigger than the target. So we need to do right minus minus. Essentially, we're just going to move one of these up once, and then we're going to keep checking if we are in bounds. And so if we aren't in bounds, it will. And yeah, like the nice thing about JavaScript is you don't have to worry about being out of bounds, but you do have to be careful because if your array does have something like undefined in it, that's where maybe having an undefined check or checking for out of bounds, you can turn on Typescript undefined check, and what that would do is if any value in your array can possibly be undefined, it'll give you an error, but it's kind of annoying, so we don't need it for this either. But if you did need it, you could turn that on. Okay, so now we have all that. Now remember we have our last condition, and so this is all another feature in JavaScript you can do that you can't do in Python. So if you use a for range loop in Python, you can't really update your I variable because it gets saved. So if you do like for I in range something, you can't really update it, I'm pretty sure, in the loop. But in JavaScript, you can actually update your variable in the loop. So like if I is 0 and you're in a loop, you can actually just say like I++, and then I will be 1, and then it will also get incremented one more time at the end of the loop. So you can make I whatever you want in your loop. And essentially what this code boils down to is it'll give I a default value, and then at the very end of your loop, it'll just do I++ that you don't see. So you could make I like a million here if you wanted to, and it would work. Okay, but I think in Python, it never really saves that value. Okay. So what we want to do is we want to make sure that, remember, when our next x value is the same as our previous one, right? Like in this drawing, we want to make sure if we're like over here, we want to make sure that if our next x value is the same, we want to skip that. And we want to skip all of those. So if there's a bunch of like x values that are the same, we want to skip all of those once we've looked at one. So we're going to do that here. So we can just do this kind of similar thing we did for the left. We can just say while nums I+1 equals nums I. Yeah, we need to do this. So while this is true, let's just increment I. And remember, we don't have to worry about being out of bounds, because once we're out of bounds, like if we're in an array like this, like 1, 1, 1, 1, eventually it will just be undefined, which is totally fine for us. Okay. And then once you are out of bounds, then this loop won't execute because it will be out of bounds. Okay, so that handles our second case. And now finally we need to return the result and hope we have our stuff correct. So I think that is correct for this first one. We could test a couple of those other ones. So we could test like the 0, 0, 0, which works. We could try 1, 1, 0, which also works. But yeah, so those are the features we used. We learned how to make a nested array in TypeScript. We learned how the sort works, and we learned the undefines. There wasn't too much TypeScript other than that, but if you do want to work on your TypeScript, you could like set all your types. But like I said, when you do something like this, when you say target equals a number, it will already make it a number. So if you try to like reassign it later on, you can't make it like a string or something if you wanted to. So you can see that. Okay, and so we can actually, so let's actually copy this up now to the LeetCode. So let's just Control C, Control V here. Let's run it. Hopefully we don't have any more errors. Okay. Okay. And so there you can see it's pretty efficient, and it's, like I said, if you don't count the sort, let's go through the time and space here. So do this every time. So for the time, essentially we have a for loop, and then we also have a while loop in here, which is basically a nested for loop because the left and the right are like nested. So, like if we have something like this, our inner loop will be the rest of the loop, right? So like this will be the first part, this will be the second part. So this is essentially O of n squared time. And for the space, it is O of 1, because if you look, we sorted, and we do have our result, but you usually don't count your result as part of the space. But other than that, we just have constant variables. So that's why it's going to be O of 1 space. But yeah, that's going to be it for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And as always, I'll be uploading this to the GitHub repo that I'll link, so you can just get all the code for all the problems and try them yourself. So thanks for watching, and I'll see you in the next one.